All right, so 4.5 is actually comparatively a pretty simple section. There isn't much new to it, okay? All it is this idea of the superposition principle. And basically what that means is that if we have more than one forcing function, more than one non-homogeneous part, we can take two particular solutions and sort of add them together to get a new particular solution. Okay, so let's just illustrate that with an example. So let's take, and we're going to take this, the equation y double prime plus y prime minus 12y equals e to the t plus e to the 2t minus 1, okay, with initial conditions y of 0 equals 1, y prime of 0 equals 3. Okay, this is actually number 28 in the book. In the section. Okay, so how are we going to look at this? So first thing we're going to do, as usual, we're going to solve the homogeneous part. Okay, y double prime plus y prime minus 12y equals 0. Okay, simple enough. We know how to deal with this. We make the assumption y equals e to the RT. We get the quadratic equation r squared plus r minus 12 equals 0, which we know how to factor. R plus 4, r minus 3 equals 0. So r is negative 4, or r equals 3. So our homogeneous solution, which I'm going to write as y sub 0 of t, equals c1 e to the negative 4t plus c2 e to the 3t. Okay, now for the particular solution, we're actually going to have 3 different particular solutions, one for each forcing function on the right. Okay, so okay, so let's say that we have y1 of t is going to give us y1 double prime plus y1 prime. Let me erase the t dependence there. Plus 12y1 equals e to the t. Okay, y2 plus y2 prime plus 12y2, that's going to equal e to the 2t. And then y3 double prime plus y3 prime plus 12y3. Oh, those should be minuses. Sorry about that. Equals negative 1. Okay, so we're going to solve each one of those independently. Now, luckily, these are all pretty straightforward. Notice there's no resonance going on, right? The exponents are negative 4t and 3t, which don't match here. So that means these are pretty straightforward undetermined coefficient problems. Okay, so y1 equals a e to the t. If we solve that, that's going to give us what? No factor, so a plus a minus 12a equals 1. Let me make some space for myself. So that's going to give us negative 10a equals 1. So a is negative 1 over 10. This one's going to be slightly more difficult. y2 is b e to the 2t. So you're going to have, from the y prime, you're going to have 2b. Y double prime, you're going to have 4b. So you're going to have 4b plus 2b minus 12b equals 1 again. Okay, you can work through that, but you'll see that I'm right. Okay, so that's going to be negative 6b equals 1. So b equals negative 1/6. Okay. And this one's easier. This one you're just going to say, well, y3 is going to have to equal some constant. So our constant's going to end up being 1 over 12. Okay, so what is our total solution? Our total solution is going to be y of t equals, let's take our homogeneous part, minus 1/10 e to the t minus 1/6 e to the 2t plus 1/12. Okay, so this is the form of the solution, and we still need to satisfy the initial conditions. So y of 0 equals 1, y prime of 0 equals 3. Okay, we can solve those pretty easily. Y of 0 equals 1. Well, let's take y prime of t first. So y prime of t is going to be what? Negative 4c1 e to the negative 4t plus 3c2 e to the 3t minus 1/10 e to the t minus 1/3 e to the 2t. Okay, so y of 0 equals 1 means we get c1 plus c2 minus 1/10 minus 1/6 plus 1/12 equals 1. Y prime of 0 equals 3 means minus 4c1 plus 3c2 minus 1/10 minus 1/3 equals 3. Okay, and these are easy systems, 2 equations, 2 unknowns. I will let you solve that on your own. Okay, all right, so that's basically the crux of what's in 4.5. Okay, all right, see you in a bit.